Let us continue with overview of cryptography. In this video, we will discuss two advanced asymmetric algorithms, that is the RSA and the Diffie-Hellman algorithm. RSA cryptography was developed by Ron Rivest, Adi Shamir and Leonard Edelman at Massachusetts Institute of Technology MIT in 1977. RSA is a cryptosystem for public key encryption widely used for securing sensitive data, particularly when being sent over an insecure network such as the Internet. In RSA cryptography, both the public and private keys can encrypt a message, while the opposite key from the one used to encrypt a message is used to decrypt it. RSA implements a public key cryptosystem as well as digital signatures. For public key encryption in RSA, encryption keys are public, while the decryption keys are not so. So, only the person with the correct decryption key can decipher an encrypted message. The keys must be made in such a way that the decryption key may not be easily deduced from the public encryption key. Everyone has their own encryption and decryption keys. For digital signatures in RSA, the receiver may need to verify that a transmitted message actually originated from the sender, that is the signature. This is done using the sender's decryption key, and the signature can be later verified by anyone using the corresponding public encryption key. Signatures therefore cannot be forged. Also, no signer can later deny having the signed message. On your screen, you can see the example of RSA algorithm. But first, let us have a background. The security of the RSA algorithm has so far been validated. Since no one attempts to break it, it has been successful, mainly because of the difficulty of factoring large numbers, that is n is equal to ab, where a and b are large prime numbers. RSA is however a relatively slow algorithm, and because of this, it is less commonly used to directly encrypt user data. RSA, as I said, is an asymmetric cryptography algorithm that enables public key encryption for secure data transmission. In this algorithm, two sets of keys are generated, a public key and a private key. The security of this algorithm is based on the practical difficulty of factorization of product of two very large prime numbers. Multiplying two given prime numbers to get their product is easy, but determining the original prime number from the product is considered an infeasible operation due to the time it would take using even today's most powerful supercomputers. This is called the factoring problem. Let us consider two components of this algorithm. E is equal to 17, which is the public component, which everybody can see, and D, which is 2753 in our case, is the private component, which is only reserved for the authority. Your public key will be E, AB, which will be accessible to everyone, and your private key is equal to D. Consider T as the plain text and C as the ciphertext. Therefore, the encryption function will be T raised to E mod AB is equal to T raised to 17 mod 3233, and the decryption function will be C raised to D mod AB, that is C raised to 2753 mod 3233. Let us consider an example that we have to encrypt a value 123. To encrypt plain text value T, that is 123, the encryption of 123 will be 123 raised to 17 mod 3233, which is equal to 855. To decrypt the ciphertext C, that is the value of 855, the decryption function of 855 will be 855 raised to 2753 mod 3233, that is equal to 123. So as of now, you must have known that if we share our private key with anyone, then it's easy to decrypt the value. Therefore, the thing you should remember is that you should keep your private key secured. In this case, your private key is D. Diffie-Hellman. Diffie-Hellman is a cryptographic protocol that allows two parties to establish a shared key over an insecure channel. Diffie and Hellman came us with an encryption method that uses only a one-way function. Many algorithms that were used before for encryption could be hacked because they use functions that were two-way. So if someone intercepts an encrypted message the information could be retrieved, reducing the security of the message. The Diffie-Hellman algorithm solves the problem of key distribution. Actually, Diffie-Hellman was independently developed a few years earlier by Malcolm J. Wilson of the British Intelligence Service, but it was classified. Diffie-Hellman is a way for two parties to securely generate a key for them to encrypt data in a subsequent conversation. It works like this. Let Alice and Bob be two people who want to have an encrypted chat. Alice and Bob are on separate islands. Alice is trying to send a box of gold to Bob. They do not want evil Trudy to be able to take the gold. To protect it, Alice has a lock and key, and Bob has a different lock and key. Alice cannot open Bob's lock, and Bob cannot open Alice's lock. When the box is on a boat, Trudy can intercept it. Trudy can open only an unlocked box and cannot break the locks of Alice or Bob. So, how can Alice send the box of gold to Bob without Trudy taking the gold? So, what is the answer? Alice puts her lock on the box and sends it to Bob. Bob then puts his lock on the box as well and sends it back to Alice. Alice will then unlock her lock and send it to Bob. Bob will then unlock his lock and retrieve the gold. Notice that this doesn't stop Trudy from intercepting the boat, putting his own lock on it and sending it back to Alice. So in reality, additional security is needed to make sure Trudy is not impersonating Bob. Therefore, Diffie-Hellman algorithms comes in use in this case. In the next lecture, we will study hashing with two types of hashing, MD5 and SHA.